Terminal velocity. So what is the terminal velocity? Very simple, students. The maximum constant velocity of your body, or it is acquired by your body while falling through the viscous medium, is called terminal velocity. Let us we take the spherical body of radius r is allowed to fall through the liquid medium. The liquid medium density is sigma. The spherical body density is rho. So if we allow it to fall down, due to its weight, it will come down. Then there will be a upthrust force. There will be upthrust which is equal to weight of the liquid displaced by this spherical body, that is U. And already we studied that this is a Stokes force, which is a upward viscous force. So to attain the uniform velocity. So this is the two forces which will be acting upwards, and one force is the weight of the body acting downwards. Hence the body, the spherical body, will move with a constant maximum velocity. So terminal velocity is the maximum constant velocity acquired by a body while falling through the viscous medium is called terminal velocity. So we know that the weight of the spherical body is m into g. Mass of the spherical body, mass is equal to volume into density. Volume of the sphere is 4 by 3 pi r cube, and the density of the sphere is rho and rho g. Then what about the U? U is the upthrust, that is upward thrust, equal to weight of the liquid displaced by this spherical body, that is m into g, mass of the liquid displaced into gravity. So mass will be equal to, mass of the liquid will be volume into density. Density, the volume of the liquid displaced is equal to volume of the sphere, because the sphere only going to displace this liquid. So 4 by 3 pi r cube. The density of the liquid is sigma into g. Then there is another force is called upward viscous force, that is called as Stokes force, which is already we are derived in previous video. So that is F is equal to 6 pi, eta is the coefficient of viscosity of the liquid, R is the radius of the sphere, and V is the maximum terminal velocity. So this W is equal to U plus F. W is equal to U plus F. W is acting downwards, and upthrust and force will be, Stokes force will be acting upwards. So if you equate these three equations by substituting this one, so this is upthrust, then the Stokes force, again the weight of the body. So I keep this Stokes force as it is, bring the this term to the right side, means 4 by 3 pi r cube, g is a constant. So common thing, I will take these things outside. 4 by 3 pi r cube, 4 by 3 pi r cube, rho minus sigma, this sigma is come this side, g. So then I need only the terminal velocity, that V alone, remaining terms will be comes to the denominator. So this pi and this pi get cancelled. Here it is 3 times, this is 2 times. Again the r is cancelled, this is r power 2. So we get 2 by 3 into 3, 9, r squared, rho minus sigma, g by eta. So this is maximum terminal velocity of the sphere when it is falls through the liquid whose coefficient of viscosity is eta. Means this is the terminal velocity. This terminal velocity is directly proportional to square of the radius of the sphere, and this terminal velocity is dependent upon the rho and sigma. Rho is a density of the sphere and sigma is a density of the liquid. If the density of the sphere is greater than the density of the liquid, the sphere will come down, it will be falling down with the some velocity, terminal velocity. If the sphere density is less than the liquid density, the sphere will rise up. Then the terminal velocity is inversely proportional to coefficient of viscosity eta. Then this terminal velocity does not depend upon the height, how much height it will take. So whatever its height, the velocity will be the uniform velocity, that is a terminal velocity. That will obey the equation V is equal to 2 by 9 r square, rho minus sigma g by eta, where r is the radius of the sphere, rho is the density of the sphere, sigma is the density of the fluid or the liquid, g is the gravity, and eta is the coefficient of viscosity of liquid. So by this way we can derive the expression for terminal velocity of the spherical body falls on the, it will be flow on the moving on the liquid whose coefficient of viscosity is eta and density is sigma.